Hello, geometry children. So, today we got our benchmark review. This is your first benchmark in high school, maybe your first benchmark ever. So, we're going to go through the problems. I'm going to try to be as clear as possible about all of it. But as always, if you have any questions, make sure you ask me or Miss Harris if you're in her class. And just do your best to understand all of it so that when you get to the benchmark, you do your best. Awesome. Let's get started. First question says, consider line T. So we have line T there. Which is the best definition of the line segment QR? So our first thing that we need to really look at here is, what is it asking? It's asking for a line segment. We have to think about the line segment. Line segments are from one point to another point, right? So that red highlighted section there. So let's read through. It says all points on line T, the 2 points Q and R, point Q, point R, and all points on line T between Q and R, the points on line T starting at point Q and extending beyond point R. So let's go through these once more. Now that we've read them, let's actually understand them. All points on line T, that's every single point. That's even past or not on this red mark that I marked off. So can that be our answer? No, because that's going to go on forever. That's a line. That's the definition of just a regular line. But that's not it. The points Q and R. Is it just these points that we're looking at? No, it's the points and the stuff in between them, right? So we can't have that one. Point Q and point R and all the points in between on line T. That is our answer right here. Try to and draw that line. Oh, gotta be a little squiggle there. Boom. Let's C is our answer. Let's just look at the last one and we'll talk about why. The points on line T starting at point Q and extending beyond point R. But what that would be is a ray. If we start at Q and go on this way forever, it doesn't really have a stopping point there. It says it extends past R, which means that it just goes on and goes on. So that's not our answer. Next, it says select from the drop-down menus correctly complete each sentence. To correctly complete each sentence. Sorry. The sets of all points in a plane that are equidistant from a given point called the blank. The point is called the blank. So, the set of points in a plane that are equidistant from a given point. Think about what that is. So let's give a given point. And if everything was equidistant around it, in order to do that, we're going to get a shape that kind of looks like this. Whoops. Drawing is not. Oh, even worse. Oh my god, I keep clicking buttons now. Like it's not meant to be. Don't embarrass yourself, John. That's what it's saying. Whatever. It's a circle. It's a circle. And we know it's not a sphere because it says it's in a plane, right? It's not in a three-dimensional plane. It would have to specify. A segment, not it. A square, not it. And the point, that is this point here, is called our center. Awesome. Next up, we have a proof. And this is going back to thinking about parallel lines and transversals and the angles that they form. So if we look at this proof, it starts off by saying P is parallel to S, and we know that because it's given. So I'm going to mark that off. P, this line. S is this line. We know that they're parallel. Which tells us then 1 and 2 are congruent because they're corresponding. And we want to know 2 and 3. Why are they congruent? The first one says alternate interior angles along parallel lines are congruent. These are not alternate interior angles. They're at the same intersection. So it's not going to be any of our parallel line theorems. So alternate exterior angles along parallel lines. No. Corresponding angles along parallel lines. No. This one is A simple one. You don't even really have to know the definition. All you have to know is that they're at the same intersection. It doesn't apply with the parallel line theorems, right? Parallel line theorems have to be at different intersections, right? So 1 and 2, we were able to use a parallel line theorem, right? Parallel lines, corresponding angles, parallel lines, right? 1 and 2. So they were at different intersections, so we were able to use it. Where 2 and 3, these are vertical angles, or angles that are across from each other. If we folded the paper along this line here, they would fall on top of each other. Our answer is D. Vertical angles are congruent. Awesome. Next up, it says in the figure shown, CF intersects AD and EH at points B and F respectively. So once again, kind of looks like we have parallel lines here, but we're not sure. What we're given is angle CBD is congruent to BFE. We want to prove that angle ABF is congruent to BFE. The first statement, it says angle CBD is congruent to angle BFE. We know this because it's given, and I'm going to write underneath. So actually, I'll write right underneath the statement. Given. This is given. Next up, it says CBD congruent to ABF. Well, first things first, we should probably go back and we should mark off what we know. So CBD is congruent to BFE. BFE. Then it says CBD congruent to ABF. ABF is right here. Right? Why is that congruent? Well, look at these two angles. CBD's here, ABF's here. It's just like the last problem. Hint, hint, hint. These are vertical angles, right? So this third reason. Vertical angles are congruent. Vertical angles are congruent. Then the last one, ABF is congruent to BFE. ABF is congruent to BFE. How do we know this? This is our transitive property. Why? Because up in our first two statements, we have two angles that are congruent to the same angle. BFE is congruent to CBD, and then ABF is congruent to CBD. So we can say that BFE and ABF are congruent. That is our transitive property. Awesome. You did it prove. Moving on. Next up, it says find the missing coordinate given the points A is 2, -2, B is 1, 1, C is 1, 4, and D is x, 5. Find the missing coordinate if the segments AB and CD are parallel. So what we know is, let's say that we have these two segments. Doesn't matter what we look like here. I'm going to just sketch them out just so we have an idea. Let's say this is A, B, it's 2, -2, 1, 1, right? And then here we have, I know this doesn't logistically make sense, but I wrote it the wrong way, so we're going to go with it. So here we have C, D, 1, 4, X, 5, right? What's happening is none of these numbers match up. We can't use it that way. But there's going to be a pattern between our two lines here. And that pattern is our slope, right? If these are parallel, then the slopes have to be the same. So what we could say is for 2, -2, how much do we move? Our x goes down by 1. And if we look, our y goes up by 3. So x goes down by 1, y goes up by 3. So we got -1. Or, well, rise over run, sorry. Rise over run. So it's really our y first. So y is, it goes up by 3. 3. And then down 1, so -1. So our slope for AB is 3. Our slope for this one has to be 3. Remember, it's rise over run. So up top, it goes up by 1. So we need to keep this the same, right? So our slope down below has to be what? That is the question here. It is going to be x minus 1. What we could do is we could set these equal, right? Let me actually take this negative sign, put it down here. We get 1 times negative 1. We're going to cross multiply, people. Cross multiply. 1 times negative 1, give me negative 1, equals 3x minus 3. Then what we could do is we could add plus 3. Back up, back up, back up. Plus 3. And what do we get? We get 2 equals 3x. Divide by 3, divide by 3, and we get x equals 2/3. There's our answer. Not pretty. That's the answer. Awesome. Next up, it says Chris is creating a triangular shaped garden. He creates a scale drawing with the coordinates A, B, and C to represent each corner of the garden. Triangle ABC has the vertices located at 4, 4, 3, and negative 3, 0. He estimates that he will need 2 feet of material for the border for every unit of length represented on the graph of the garden. Write an expression that can be used to determine the amount of material needed for the border on the side of the garden that represents by these vertices on the graph. So what we're going to have to do is use our distance formula here, right? But also we need to write an expression that determines the amount of material needed. For every unit of length, we could then find it out, right? So first, let's write the idea out. This is for every unit of length, which would be our distance formula. Our distance formula, if we remember, is d equals the square root of, double check this so that we don't get it wrong here. Wrong screen. Okay, that's what I thought. D is x2 minus x1 squared plus y2 minus y1 squared. This is our distance formula, right? Which would tell us the units between these two, how long that line is. So what we then would need to do is we could get rid of this d and we can multiply it by 2. And this formula would give us, we could say M for material, right? It would give us the amount of material needed for the border. Then what we could then say is we could plug this information in. If I label my things, I could say x1, y1, x, that's a y, on an x, x2, y2, right? We plug everything in, we get 2 times square root. X2 is negative 3 minus 4 squared plus 0 minus 3 squared. Right? We could solve it then now, too. It's not asking us to do this, but we're going to do it anyway. We get 2 times the square root. Negative 3 minus 4. Give me negative 7 squared plus negative 3 squared. So negative 7 squared is just 49. We get 49 plus 9, which is going to give me 2 square root 58. That's how I'm going to leave it. That's what I'm going to leave it as, because once you have a square root, if it doesn't simplify, that's what I'm leaving it as. So we get our answer there. Awesome. So we just really need to use the distance formula here. Have that idea of the distance formula. Next up, we got in the coordinate plane, quadrilateral ABCD has vertices. A, 2, -2, 3. 4, B is 4, 5. C, 10, -1. And D, 8, -9. It says let EF, GH be the midpoints of A, B, BC, CD, and DA respectively. Prove that the quadrilateral blah 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 is a parallelogram. Enter your proof base, provide it. So what we have to do in order to do this, we have to find the midpoints of each of these. So first of all, find E. E is going to be the midpoint of AB. E. The way we find it is for my X, we do 4 minus -2. Sorry, just give me 1 second. Just thinking about what. Wait, how do you find the midpoint? Oh man, guys, I'm getting old. Having a brain fart this morning. Midpoint formula. Oh, you add them, you don't subtract them. My bad. I apologize. So, comma. So what I did was I took my x coordinate for B, my x coordinate for A, add them together. Then you do your y coordinates. 5 plus 3 for 2. Right, so E is going to be at, E will be at 2 plus a negative, 4 plus -2 is 2. Be at 1, comma, you're going to give me 8 up top, divided by 2 will be 4. That's E. Let's find F. Next up, we got F. So F is going to be between B and C. We're doing with 10 plus 4 divided by 2, comma, 5 plus a -1, 2. This is going to give me F is at 10 plus 4. Gives me 14 divided by 2. That's 7. 5 plus -1 will be 4. Divided by 2 is 2. Now we got F. Midpoint formula again. Let's find G. So G is going to be at, it's going to be between C and D. So we get 8 plus 10 for 2, comma, -9 plus -1, 2. This is going to give me 8 plus 10 is going to give me 18. Divided by 2 is 9. -9 plus -1 will give me a -10. Divided by 2 will be a -5. All right. We only have one more side to find the midpoint up. One more point. Whoopsie. Oh, there you go. Got to find this last one. We got to find H. H. And once again, do the coordinates. It's for between D and A, so we're going to have to use 8, -2. So 8 plus -2 by 2, comma. And then -9 plus 3 over 2. So up top, 8 minus 2 is going to give me 6. 6 divided by 2 is 3. And then here we have -9 plus 3. That's going to give me also, that's going to give me -6. Minus, divided by 2 is going to be -3. Whoops. Wow, I keep clicking buttons. I shouldn't be clicking. There you go. But now we're not done, because what we need to do is we need to find the slopes of some of these. So for EF, we want to find the slope. So EF. What is my slope? Well, my slope is going to be my rise over my run. So the difference in my y's over the difference in my x's. So it's going to be 4 minus 2, which is going to give me 2. 1 minus 7, give me negative 6, which we could also say is negative 1/3. So EF, the slope is negative 1/3. Next up, let's find it for FG. And what this should be is the opposite reciprocal, because these two sides, actually not necessarily, but what we do need to find is, actually let's not do FG first. I want to find the side opposite. What would be the side opposite of EF? It would be GH. So let's find GH, because if they're parallel, then we have the parallelogram. For GH, we have 9 minus 3, which would be 6, and then negative 5 minus negative 3, which would be, whoops, I did it the wrong way again. Sorry, guys. Jeez Louise. Should be y's. So it should be negative 5 minus 3, a negative 3, which would be negative 2, over 9 minus 3, which would be 6, which is just what we had up top, right? Bring that negative out front, and you get negative 1/3. Since these are the same, we have a parallel line, or we have the parallelogram. Next up, so this one looks complicated. It's going to sound complicated, but it's not as bad as it originally seemed. So when we start off, it's asking us, what is the sum of the perimeters in units with 5 squares? And it says, what are the areas? First things first, we just need to find the length of all these sides. First up, these squares that fall on perfectly on our grid lines are easy. We could just count. All the sides are 3, right? That's an easy one. But this middle one is where the problem is. What we could do is use our distance formula again. Remember, D equals the square root of x of x2 minus x1 squared plus y2 minus y1 squared. So let's plug that in, but for these points here, we're going to just find one side. If we find one side, it's the square, so all the sides are the same. So first one's first, we're going to have 0, 4. So that's 1 point, 0, 4, and then we got 4, 0. So let's plug things in, right? x1, y1, x2, y2. Awesome. We get D equals the square root of x2, which is going to be 4, minus 0 squared, plus y2, which is 0, minus y1, which is 4 squared. So here we have D equals 4 squared plus negative 4 squared, square root of that whole thing. Then we get D equals square root of 16 plus 16. D equals square root of 32. In this case, we're actually going to simplify this radical, right? And what it comes out to be, let me just double check. Well, we could divide this by 16, right? 16 divided by 2, which would, so this is going to really be square root of 16, square root of 2, right? Times the square root of 2. Square root of 16 is going to be 4, so we get 4 square root of 2, our side. That's each of these sides here, right? So now we could add these things up. So what we know is we can find the perimeter. How many sides of the smaller triangles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We can say 3 times 16 plus 4 square root 2 times 4. And then over here, what do we have? We have 30, and then 6, 12, that's 18. So 30 plus 18 will be 48 plus 16 square root 2. And this is the weird thing. Right here, unless we do a decimal, which it's asking us to do because it's saying round to your nearest tenth. That's what we're going to have to do. But what you could do is just plug this into a calculator, right? Go to Google, you could type in 48 plus 16 square root. Actually, can't do it on that calculator. But what I'm going to do is I'm going to say square root. Actually, I'll just go to a real calculator. What you guys could do is go to Desmos. If you don't know about it, you should. Desmos.com. I'll bring up the calculator. You could just pull up the calculator and you could type things in. They have a little keyboard with all the symbols for you. So you could say 48 plus 16 square root, enter. And it's going to give you 70.6. So our answer here is going to be 70.6. And that's the nearest tenth. So that's our answer. Next up, now we want to find the areas. So what I'm going to do is find the area for each. 3 times 3 is 9. So each of these are going to be 9. Right? So for each of those small squares, we have 9 plus 9 plus 9 plus 9. Well, my big square now is what I need to find. And that's going to be the two sides times each other. So 4 square root 2 times 4 square root 2. So what's going to happen here? 4 times 4 is 16. Square root 2 times square root 2 is going to give me 2. There's really going to be 16 times 2, which is 32. So now we can just add this 32 to the end here, right? And we get 9. Calculator here. 9 plus 9. 9 plus 2. That should be 68 square units. There's your answer. We solved this problem. Once again, if you don't understand this, watch it over again. And then hopefully you understand next time. Or you could ask questions. Next up, it says if polygon is translated, which of the following characters of polygon are the same? Side lengths. So translate means to shift it up, down, left, right. So it's like if you take a piece of paper or let's say your phone, right? And you put it in front of you and you just slide it up, down, left, or right. What's changing about it? Are the side lengths changing? No. And this is asking which of the following characters of a polygon are the same. So we're going to select the ones that are same. So they're the same. Area is the same. Coordinates of the vertices won't be the same. Perimeter will be the same. And slopes of the sides will also be the same. None of that's going to change depending on where it's located, right? And these could be located wherever you want, and they're all going to stay the same. Next up, this triangle DEF has vertices. D, -1, 5, E, -2, 3, 2, and F, -1, 1. In the coordinate plane, triangle will be reflected over the x-axis and then rotate it 180 degrees about the origin to form D prime, E prime, F prime. What are the vertices of this triangle? When you flip something over our x-axis, the y coordinate changes, right? So these are all going to become -1, -5. That sign changes. -3, -2, and then -1, -1. So reflection over x axis. Rule is y coordinate is opposite. That's our rule, right? So that's what we get here with these numbers. So everything just becomes, everything that was positive in my y, my second number here, it becomes negative. If it was negative, it would then become positive, right? And then we want to rotate it 180 degrees about the origin. So let me just double check this rule. Sometimes I forget too. So our rotation rule, so 180-degree rotation. My x, y switches to negative x, negative y. So whatever's negative or whatever's positive becomes negative. If it's negative, it becomes positive. So then our final answer is d prime will be 1, 5. E prime will be 3, 2. And f prime will be 1, 1. Awesome. Next up. This one is asking us what transformations happened to get ABC onto A prime, B prime, C prime. Well, what we notice is the shapes are facing the same way. So the orientation is the same. So that means it's not a reflection. It's not a rotation. Really, we only have one option here, and it's going to be a translation. So where do we move it? So what I like to do is just go from one point to another. So I'm going to do A. We're going to outline what A did. A went down that many, and then this. So it's a translation. Down. 1, 2, 3, 4. And then to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And what I'm going to do is I'm also going to write the rule as like with my x and y. So we could say x plus 9 comma y minus. That would be the rule here. Translation rule. You're adding 9 to every x and you're subtracting 4 from every y. Next up. Which sequence of reflections will map the rectangle onto itself? So for this to happen, we need to flip it down the middle. So one of the middles we would have to flip, right? So it says a reflection over the x-axis followed by a reflection over the y-axis. Reflection over the x-axis followed by another reflection over the x-axis. Neither of those are gonna, actually that one, we'll do it right there. You reflect it over the x-axis and then follow it back over the x-axis. That's our answer. If you do the same thing twice, reflection-wise, it's just going to bring you back to normal. Next up, got some little bit of proofs. And we've seen this proof before. We have seen this proof before. Also, we're almost done, guys. I know, hold in. I know it's long. Right there. So, what is this proof, right? So let's look at what it's saying. First up, it says draw a line BD parallel to line AC. Well, whenever it tells you to draw something, and it's a dotted line like that, we could just say construct. Awesome. Then next up, if we're missing everything here, right? Oh no, what do we do? Well, let's look at our next line. It says angle 2 plus angle 4 equals ABD. ABD. Angle 5 plus ABD equals 180. That's our angle addition postulate. What do we have below that? Angle 5 plus angle 2 plus angle 4 equal 180. That's my substitution property. And we have angle 1 plus angle 2 plus angle 3 equals 180. But wait, what happened there? Well, what happened there is that they are just swapping things out. So up here, what we need to look at is right here. Boom, 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 boom. That those are congruent. We could say angle 5 is congruent, angle 1, and then angle 4 congruent, angle 3. And our answer here is alternate interior angles. Awesome. Then when they swap it out down here, once again, it's substitution. Use it back to back. And then we get our answer. Because then here they're able to swap out angle 5 for angle 1. Here they swap out 4 for 3. Awesome. Next up, right here, we have parallel lines. Well, what we know is that corresponding, and we have that hint there, the corresponding angles are congruent, so we could set these equal. So what we could then say, since these two are congruent, because they're corresponding, we can say 2x minus 45 equals x plus 30. Subtract x both sides, and we get x minus 45 equals 30. We add 45 on both sides, and we get our final answer to be x equals 75. That one's simple. All you have to say is, oh, they're corresponding, which means they're congruent. Well, congruent means same shape, same size, which means equal. Set them equal, solve the equation. Next up. And this is our last one. We're right there. All we have to do is complete this proof and we're good to go. So let's look at what we have here. It says the figure shows RSUV with RV and SU parallel and congruent segments are marked. Oh, quadrilateral RSUV, by the way. Prove that RU bisects SV. And we don't actually have to do it. We just have to select the things. This says select the appropriate reason for each statement. So up top, it gives us the given, and then it says KSU is congruent to KVR. KSU, KVR. KSU, KVR. Well, how do we know that? And then it says SU, K, and SU. Oh, how do we know? They are alternate. Sorry, guys, I'm just trying to think this out in real time. KSU is which one? Here. And KVR. Oh, that's why I was looking at the wrong side. Okay, yeah, these are alternate interior. So this is alternate. I need to start over. Alter. And the next one says triangle SUK is congruent to triangle VRK. Reason is by side, side, side. Side, side, side. Let's see. Would have enough sides. Or actually, I thought we were just talking about sides here. I lied again. I apologize. Since we know RV and SU are congruent. RV, SU. And then we have, let me mark off my other angles. SUK, SUK here. And then ARV, RV here. Right? They're both alternate interiors. We'd have angle, side, angle. Angle, side, angle. Triangle. Or angle, side, angle congruency theorem. And we're done. So I know this is a lot. I know there's a lot to go through, but this also gives you general ideas to look up. If you are stuck on any of these, you could always ask me a topic, and then I could send you YouTube videos on them to better explain them so we don't have to go all through it again. But once again, if you have any questions, make sure you ask, and I wish you guys luck.